Today I am going to discuss some of the important topics for solving certain problems in electronics and devices. So today I am going to discuss about drift current, diffusion current, mass action law. So we'll start with drift current. Drift current is the flow of electric current due to the motion of charge carriers under the influence of an external electric field. So this we have seen in your previous classes. So now how drift current can be written as in terms of density, current density J. So Jn due to free electrons is equal to the charge of the electron into the number of electrons, free electrons per cubic centimeter, the mobility of the electron and the applied electric field. Similarly, you can write for p-type. So the hole and the mobility of the hole into the electric field upon the charge. So these are the equations, and you know that the charge of an electron would be 1.6 into 10 to the power minus 19 coulomb. This is for drift current. So the next one is the diffusion current. So in a semiconductor material, the charge carriers have the tendency to move from the higher concentration region to the lower concentration region. Thus, the movement of charge carriers takes place, resulting in a current called diffusion current. So this diffusion current will depend on these three parameters: the material of the semiconductor, type of the charge carriers, and concentration gradient. Here the diffusion current density due to hole is represented as Jp equal to minus q dp upon dx. So now I am going to tell you the reason why minus is put. So here, as the distance increases in your type of material, p-type or n-type, the density tends to reduce. So I am going to put negative over here in order to say that during the positive x direction I will get a positive over here. And similarly for n-type, q dn upon dx. So here the concentration gradients would be dn upon dx and dp upon dx. The diffusion coefficient would be dn and dp. These are the diffusion coefficients. So now if I want to know the total current, I drift plus I diffusion is the total current. Now I can write Jp and Jn. So I have put the drift and the diffusion together. So if I am going to solve my equation, I will be neglecting this term and then solve Jn plus Jp. So I am going to add these two, Jn plus Jp. So I can get a common term Eq out, and then I can have the rest of the parts in it. So now I write this Q upon all this function as the conductivity. So J is equal to the conductivity into the electric field. So I have written this over here. What is this conductivity? And in case if I am going to use a pure semiconductor, which is N is equal to P is equal to Ni, then I can substitute Ni over here, and I can take Ni common out. So Qni, that would be Qni of the mobility of electrons and the mobility of the holes. That is your conductivity. The next topic is the mass action law. The mass action law states as Np is equal to Ni square. So number of free electrons per unit volume, number of holes per unit volume is equal to your intrinsic concentration. So if you want to know the charge density in N-type and P-type semiconductor, this is what we have to follow. This small n determines the holes or electrons. Now here it is electron. The capital N determines the type of the material, which is N-type or P-type. Nd says that it is the concentration of the donor atoms in an N-type semiconductor. Since it is N-type semiconductor, D is the donor. So Nn is equal to Nd plus P of Pn. So we can write approximately this would be equal to Nd. Similarly, if I want to know what is Pn, now how did I come to this equation is from the mass action law. You can say that Np is equal to Ni square. I can write Nn into Pn equal to Ni square. So I can equate it, I can get this equation. So I can say that this will be very, very small. Similarly for p-type. So I can get, if I get for n-type, it is a donor. If I get for p-type, it is an acceptor. So I get the same using the same principle, mass action law. I get the same equation. I can substitute and then say Ni upon Na. Ni square upon Na. So if you want to know the conductivity of n-type, so have the equation for this. So conductivity of n-type is Q upon Nn mu n. I can write Nn as Nd. If you want to do it for p-type, it is Na. So now you can see that this Nd and Na plays a very important role. So if Nd is very greater than Na, then the p-type will change into an n-type. If Na is very greater than Nd, n-type will change into a p-type. Now that's it for the class. We will see the problem in the next class.